Hello everyone, welcome back to the video. I hope you all are doing very well. So in this video lecture we are going to learn about the analog and the digital signals. So one of the major functions of the physical layer is to move data from the one electromagnetic signals across a transmission medium. So both data and the signals that represent them can be either analog or in digital form. So the data can be sharing analog or digital. The term analog refers to the information that is continuous. Digital data refers to the information that has a discrete state. For example, an analog clock that has hour, minutes, and the second hands give information in a continuous form. The movement of the hands are continuous. On the other hand, the digital clock that reports the hour and the minute will change suddenly from 8:05 to 8:06. In analog, such as the sound made by the human voice, take a continuous values when the someone speaks, an analog wave is created in the air. So this can be captured by the microphone and converting it to an analog signal or sampled and converted to a digital signal. Digital signal take a discrete values. For example, data are stored in the computer memory in the form and the ones and the zeros. They can be converted to a digital signal and modulated into an analog signal for the transmission across a medium. Analog and digital signals, likely the data they represent, signals can be either analog or digital. The analog signals has infinitely many levels of intensity over a period of time. The digital signals, on the other hand, can have only a limited number of the defined values. Although each value can be any number, it is often as simple as 1 and 0. Periodic and non-periodic signals. Both analog and digital signals can take one of two forms, periodic and non-periodic. The periodic signal completes a pattern within a measurable time frame called a period and repeats that pattern over subsequent identical periods. The completion of the one full pattern is called a cycle. A non-periodic signal changes without exhibiting a pattern or the cycle that repeats over time. Both analog and digital signals can be periodic or non-periodic. In the data communication, we commonly use periodic signals and non-periodic digital signals. Periodic analog signals. A periodic analog signals can be classified as a simple or composite. A simple periodic analog signal, a sine wave, cannot be decomposed into the simpler signals. A composite periodic analog signal is composed of multiple sine waves. Now we are going to discuss about the sine wave. A sine wave is the most fundamental form of the periodic analog signals. When we visualize it as a simple oscillating curve, its change over the course of a cycle is smooth as and consistent. A continuous rolling flow. A sine wave can be represented by three parameters: a peak, amplitude, the frequency, and the phase. These parameters fully described a sine wave. Peak amplitude. The peak amplitude of a signal is an absolute value of its highest intensity proportional to the energy it carries. For the electric signals, peak amplitude is normally measured in volts. The periods and the frequency. Period refers to the amount of time in seconds a signal needs to complete one cycle. Frequency refers to the number of periods in 1 second. Period is the inverse of frequency, and the frequency is the inverse of period. As the example formula shows, f equals to 1 upon t and t equals to 1 by f. So units, equivalents, and units. Second is equivalent to 1s and unit hertz. So these are the following units and the equivalents. This is the block diagram of a signal with high peak amplitude, and this is the signal with low peak amplitude. So that's all for the today. Thank you so much. I hope you like the video.